Hey physics people, Lenny Hortensi here, trying to help anybody that's still confused for lab number 1 about sig figs and uncertainty. So let's just do a quick little mini lesson and see whether or not this might help. Let's say I had in my pocket 500 bucks, but they're all $100 bills. So $500, but I could be off by 100. So this has one sig fig in it, even though there's 3 numbers down there. These zeros don't count because the way I wrote it without a decimal point means that this is the guess, and the guess is the last sig fig. So I could have $400 in my pocket if I miscounted, or maybe a couple stuck together and I got $600 in my pocket. But I'm guessing that I have $500 in my pocket. So that's one sig fig. Now, beyond sig figs, there's a thing called uncertainty. So uncertainty is kind of like sig figs on on speed. It makes it more accurate and gets it even more clear. So I could say 500 bucks plus or minus $100. That's a better way of saying that I'm actually not sure on whether or not I have $500 in my pocket or I have 600 or 400. All right? Now, what if instead of having $500 in my pocket and it was all $100 bills, what if I had $1 bills in my pocket? Then what if I miscounted on that one? Now I have $500 in my pocket, but how do I tell everybody that it's $500, but this isn't a guess, this isn't a guess, I'm guessing that it's right there at the ones place. So there's a couple ways you can do that. You can either put a decimal point there, and now that means that's significant, and I'm guessing. That means instead of 500, I might, if I miscounted, have 499 bucks in my pocket or $501 in my pocket, but I'm guessing that there's $500 in my pocket. You see how that is the sig fig. So there's 1, 2, 3 sig figs. If I want to be more accurate, then I could say plus or minus $1 because the guess is in the ones place. Doesn't that make sense? Hopefully that makes sense. All right, now this is where it gets a little weird. What if instead of having $500 in my pocket and they were $1 bills, then what if I had $2 bills and $1 bills and $5 bills? Then I could screw up and be off by 5. So it would be more accurate to say plus or minus $5. If I had $5 bills that all could add up to 500, that means it could be 495 bucks, it could be 505 bucks. But see, the guess is still at the ones place because 5. Do you see how uncertainty is more accurate than just talking about sig figs? So uncertainty is sig figs, but more. It's more accurate. All right, now comes the real crazy stuff. And this is where you might want to pause the tape and see if you can figure this out. What if I said that I had $500 in my pocket, but I had $10 bills? So that means it might be 500 bucks, but it might be 490 bucks, or it could be 510 bucks. How do you do sig figs in such a way where everybody knows that the guess is at the tens place? Now, you can't just do 50.0 because that's not 500 bucks anymore. That's 50.0 bucks. So you can't just put a decimal point there. That won't work. So how do you tell everybody on the planet that you have 500 bucks in your pocket, but you're guessing at the tens place? Pause the tape. Think about that. Tape. Listen to me. I don't even know what I'm talking about. This might be on YouTube. There's no tape. Everything's zeros and ones. All right, so folks, the only real answer to that is to change it to scientific notation, which is 5.0 times 10 to the second dollars plus or minus 0.1 times 10 to the second. In other words, the guess is a tenth of a hundredth. Here's hundreds. This is a tenth of hundreds, which is 10 bucks. So I'm plus or minus a tenth of 100 or $10. So sometimes scientific notation is the only way you can do this and still make sense. All right? Now I hope that cleared up a little bit on sig figs and uncertainty. Now comes the twicky part, and that is this. What if you want to find the volume of a room? Which, if you guys are doing your lab, you got to find the volume of a room. And the volume of the room has, I don't know, let's say 13 meters, and you think plus or minus 1 meter. And then somebody else measures it way more accurately than you, and they measured 9.2 meters, and they think they could be plus or minus 0.2 meters. Now, do you see that when you do your lab, you want to have your uncertainty agree with the guess? The guess here is the ones place. That's the last sig fig is the guess. So you can't say 13 plus or minus 0.05, because then you're saying you're only uncertain by 0.05, but you're guessing at the ones place. This has to jibe with this. This has to agree with that. This is the tenths place. So this could be plus or minus 0.5 or plus or minus 0.2 or plus or minus 0.1, but it can't be plus or minus 1 meter, because you're saying you're guessing to a tenth, and then you're saying, yeah, but I'm uncertain to a whole meter. So this has to agree with this. And your final answers, what I'm looking for on your lab, have to agree like that. All right, let's try another one. Let's say the third dimension, the height, is 3.44 meters. This person guessed to the hundredth of a meter, which is a centimeter, and he thinks or she thinks it could be off by 0.05 meters or 5 centimeters. See, the guess is the centimeters and the uncertainty is the centimeters. So how do we do this? How do we multiply these three numbers together and get uncertain?